Can you hear me?
Yes, I can. Yes.
All right. So I would like us to, make this meeting worth it. So I know that for every questions, I don't know what we are dealing with, but for every questions or whatever topic we're talking, I want it to be organized. You understand? I know people have questions. So as you're presenting, maybe we are trying to treat a particular project that we've done in the past. So I feel that when we take it one after the other, like maybe treat question one. When you're done with question one, any question regarding question one comes in, people can ask your question. Not while you are presenting, people are saying, oh, wait, how did you do this? And different people are talking. It's going to make the whole thing very tiring and you will be stressed yourself. So I would advise that people write down their questions. When we are done with a particular topic or a particular phase in the topic, ask your questions. So when we move to the next questions or next topic, we are not going back again. So and everything is
Okay.
properly organized. That's just my suggestion, please.
All right. It's noted, and thank you for that. So I believe everyone could hear that suggestion. So it's just a way for us to maximize the time that we have, and also ensure that we all get the best of this meeting, so that we won't just be here without having the necessary knowledge that will help us. So if we have question, we can write it down, and instead of interrupting or intercepting in the process of presentation, we can just wait at the end, and for all the good and for the best. All right, thank you so much. So I'm sharing my screen now, and I'll discuss on what we are dealing with today. Okay, good afternoon, everyone, once again, and I'm happy to be here to have everyone with us, and I'm so happy that we are taking this step of collaboration and also studying together in order to get the best out of this ALX journey. All right. Can everyone see my screen?
Yes, I can.
Okay.
Yeah, come to.
All right. We don't want to waste time like, okay, introduction and all of that. There's no need for that. We are all here to just learn and to just share ideas. And based on what we have today and based on the topic, today we'll be dealing with shell permission as regards the next project that is coming regarding the ALX project. We're having shell permission, and then after shell permission, the next thing will be um, shell input and output. So it is tagged shell redirection. Okay, but what we'll be dealing with starting with today will be covering all the whole concept of shell permission. All right. So, and I've been able to create a PowerPoint slide uh, to break down to help focus on the necessary thing that we need to, and also to help with this presentation in order to maximize it and have the best of it. Everyone can see my screen, right? You can see the presentation, right?
Yes.
Okay. So we'll be starting with shell permission, and this is the study outline. So we'll be looking at what are shell permissions. We'll be looking at the multi-user feature of Linux. We'll be covering the concept of file sharing and permission or file permissions. Okay, we'll see how to view the permission settings of a file or a directory using the ls command. Also, we'll talk about the representation of a file and directory with their permission. We'll be looking at how to change or modify permissions on files and directory. And that is basically using the chmod or chmod command. All right. And then we'll be looking at the file permissions, the permission model in Linux, which are read, write, and execute. Okay, and then there are different permission method, different permission model in Linux for implementing permission on file. Is actually two. I was rushing and I couldn't gather everything, but this is it here. We have the octal notation method and we have the symbolic notation method. So all of these things we will look at. So let me don't waste time with all this outline. I believe we can all see it. And then we'll look at how to change file and group ownership. That is moving from changing permission mode on files and directories onto changing ownership mode on files and directory. Okay, so just a brief overview to understand this concept. Looking at shell permission, we can understand that the Linux or the Linux operating system is under the operating system categories Unix. Linux is a type of a Unix operating system. So Unix operating system is according to the name Unix, that is it is a single user operating system. Single hello. It is an operating system that has a single tree. That's why they call it Unix. Uni from the word uni. It has a single tree whereby it has from the tree it has different branches where it can now what it can give access of directories and files to multi users. All right, that's just a basic explanation from me. Okay, so a type of a Unix operating system is Linux, and Linux it is a multi-user and multitasking operating system, and this means that more than one user can be using the operating system and the computer at the same time. Okay, so in the aspect of the ability of a Unix operating system to give access to many users to access the same computer at the same time, that is why they call it a multitasking and a multi-user operating system. And at that point, every person from different places can access the same computer and do every sort of manipulation and um, modification according to permissions given to each user. For example, looking at this, the Unix OS can be linked like having a single house, but it has different bedrooms assigned to it. They're attached to it. So each of that bedrooms, different persons have access to the bedrooms, and each of the bedroom they have keys which give you access to each of the rooms. So that is just like a Unix OS. See it like a house with different rooms inside. Does that single house have different rooms inside allocated to different persons, and each person they have keys to access it to do what they want to do inside the room. Okay, so another illustrative example is how if you look at the ALX project that we've been working on so far, if you look at how thousands of persons are accessing the sandbox and then using the same terminal. We are all using the same type of terminal, and each of the terminal allocated for different person for us to perform different actions on the terminal. So sometimes some persons even have access to use the terminal by connecting the terminal to the Git to how will I say a virtual box. Okay. I want to say Git bash before, that's a different thing. So a virtual box. So a virtual box is like the same Ubuntu OS that we have been accessing on the sandbox. We can have access to connect it to our computer instead of going to the intranet and accessing the sandbox and using the web terminal there. We can actually connect it to a virtual um, Linux OS on our laptop and then have access to the files on the terminal. So that's all of these features are all possible because of the power of the Unix OS ability to have multi users and multitask on the operating system. Okay, so looking at it that okay, different persons can have access to um the operating system. Different persons can have access to the Linux or whichever workstation. They can have access to it and make modification. It will be necessary that there are permissions given to each user or group of persons or every other person in order to make sure that there is security and in order to make sure that um, the wrong files are not tampered with. So that is the reason why the concept of shell permissions comes. The same way I illustrated that a single house with different bedrooms inside of it allocated to different person in order to ensure um, the the protection of properties and files and belongings and every other thing. That is why they allocate keys to what? To each of the rooms and also separate the rooms to different persons that this place belongs to you. And that's just the concept of shell and Linux permissions that we want to talk about so that we can understand how to use it. And also when we find ourselves working with the Linux operating system, we can be able to know, okay, all of the different permissions and all of the different commands. When we see notations, we know what they mean and we're able to work around it perfectly. All right. So now the Linux permission model. In Linux, there are three sets of users who can be given access and usage rights. We have the file owner, or we have the owner, or we call it the user. We have the group members, and then we have every other person. Okay, so we have the owner, the group members, and every other person or others. So a short form is when we say you call it the U for user, G for group, and O for others. All right, and now these three set of persons, there are now three set of permissions that is available which can be allocated to these three sets of persons. We have the read permission, the write permission, and the execute permission. So the read permission means that you can have access to read the file alone, but you cannot make changes or any modification to the file. It can be of a file, it can be of a directory too. Now, for a file, when a read permission is allocated to a file, it means that you can just view it, you can just see it, but you can't write, you can't change. Write means to change or to, yeah, just it, to change or to modify. All right. So you can only read when you have only read permission, you can only just see it. And but you can for a file, but you cannot modify it. And for directories, when you have read permission on directories, it means that that directory you can list files that are there, but you cannot create files. So this is how it works. Read permission on file, read only permission when it is only read permission on files means that you can only read the file, you can cut CAT the file and it will display, but you cannot do VI on that file and then it will open and you would say you want to edit anything or add anything to it and then you now save. It cannot work when it is only read permission on a file. When it is only read permission on a directory, it means that you can have access to list the number of files of subfolders, you understand, on that directory, but you cannot create, okay, you cannot create files or directories or anything on the directory. Now the write execution, it is explainable that you have permission to be able to write, to modify, make changes, even to delete on it. Okay, and then execute permission, it means execute permission is mostly on programs or softwares. All right, is everyone with me? Hello. Let me see.
Yes.
All right, because I'm on full screen of the display. All right, okay. So the execute permission is mostly on programs and applications whereby you can run it, okay? And they are like mostly executables, okay? For example, if you have downloaded applications on the internet before, if you look at the extension, when I mean extension, if you look at the end part of of that application that you downloaded, especially for Windows, the extension is usually exe.exe. And also, sooner or later, when we start using C programming, C program language, when we get into C programming language, we will see how files are being compiled from source code to object code. So at the point whereby they are being compiled to object code, that is to machine code, the final compilation is they become an executable. That is, you have options to be able to open it over and over instead of recompiling. You don't have to recompile. Once it has been compiled once, it becomes an executable that you can use and reuse over and over. All right. So um, the three set of permissions available: read, write, execute, and it is only possible on three persons: the user or the owner, the group members, and everyone else. All right. So now, when how does it look like? How does when we talk about okay, read, write, and all of that on file? How do we know? How do we see it? How do we identify? This is the way um a file, permissions on files are being identified or being displayed. Okay, if you look at this diagram here, we have as it is being labeled, we have the first side here talking about the file type. It indicates that it is a regular file, and they tell us that when it is D, it indicates that it is a directory. The second one here, we have triplets. They are in trees. We have RWX, 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 and the first three, after the indicator telling us that it is either a file or a directory, the next thing we are to see is to tell us the permission rights or the permission um, options on the user. So this is it here. We have the indicator telling us what type of file it is, probably a file or a directory. The next thing is permission rights on the user. The next triplet is permission rights on the group. And the last triplet is permission rights on every other person. So looking at it, the first triplet here is the permission right for the file owner or the user, and this permission is full permission. It gives the user the ability to read it, to write it, and to execute it. Okay, while the other one too, it gives full permission for the group members, as we can see, for group um for group owner of the file, for the group members of the file. Okay, so I'm trying to look for something to, okay. So why the last one is for others. All right, let me try to illustrate this using my git bash so that it can really make sense. Okay, so this is my git bash. Git bash is different from um, when you are working in a real or an actual Linux environment. It's just that as it is that we have git bash, you can run Linux commands on it because Git itself was created using shell. Okay, so that's why we can do all the shell commands on it. All right, so for example, I'm on my I'm on this working directory and I want to list my files that are here. I list files. The ls alone lists the files there. But when I want to view the permission there, I will do ls with the flag L, and this will list every of the permission on all these files and directory that are being listed. Now let us watch. It's too big. Let me reduce it. Now look at it. Excuse me. If you look at it, this is telling us that we have a total of, it gives us the total number of files here. Okay. Um, it's given a total number of files on this directory, but there are some ED files that are not displayed here. Now looking at this file here, license.txt, this is the name of the file. This very one here is this permission right displayed on this file. And as we said the other time, the first indicator, the first man here indicates, is an indicator that tells us if this is a file, a regular file, or a directory. Okay, so when it is dash, it indicates that it is a regular file. And when it is D, just like this one here, it indicates that it is a directory. And if you look at this, it is blue, showing that it is a directory. All right. So there are three colors also that is used to identify, aside the indicator, probably a dash or whatever. There are three colors you can use to know to differentiate between a file, a directory, and an executable file or an executable. So when we have white, when it is white, it is it is a regular file, and when it is blue, it is a directory, and when it is green, it shows that this is an executable. You can see the extension here, exe, git bash.exe. So now look at this file here. The right privilege or permission that we have on it is, we have the permission, the user. Okay, don't forget I said we have three set of persons that permission applies to: the user, the group, and the others. Okay, or everyone else. So now for the user, the permission that is attached to the user is just the ability to read it and ability to write, that is to modify. But it does not have the executable permission, because this man here obviously is not an executable file. It is just a regular file. Okay, so now that means, that implies that if I should cat, if I should do cat license.txt, it is going to display what is inside for me. So it will read it for me. So that is that. Two, if I do vi license.txt, of course, it will give me opportunity to even make what? Modifications to the text that are inside license.txt. As simple as that. That is for me being the user and the owner of this system. Now, the first three, one, two, three. Now, the next three is for what? Is for group members. Probably I give access rights to another set of person who is able to connect via SSH, okay, to my system, and the person have access to be able to open git bash, to run git bash on his computer through the network. The person have, okay, I for that person, it now depends on which category I place the person. Either probably on the network, I place the person to be on the group network for group members, or to be on everyone else. Okay, this thing is under network, uh, networking. They're like networking concept, but let's just understand the basic thing that we're talking about here. So this person have access, the group members have access to just read it, just to do cat or less license.txt, and that's all. They cannot write or modify anything there. And the same thing applies to everyone else. That is for this file, license.txt. This is basically what we really want to focus on. The other things that are here, they have meaning too. And this one here is talking about the name of the user. This one is talking about the access key. I think so. We'll check it. I'm not cramming anything on my head, but there are resources that defines the full structure of everything here. But what matters most is understanding the basic concept of how this thing works. Okay, so like that. Now for a directory, we can see this is a directory and these are the access rights or permission available for the user. You can read, write, and even do even create executables. Permission rights on directories is different from the way it works on files. For directories, that means inside this bin, I can create, I can open it, that is read it. I can write, that is I can create stuff inside. Execute, I can even run executable files that are inside. Okay, now let's go to the outline. Okay, let me just do an example. Let me copy this license.txt. Okay. Oosh, sorry. In Linux, we don't use Control C. Oh, in shell. So I'm copying it, and then I want to do cat. Let me clear the screen. And then I want to do cat, paste, right click, paste. Okay, let me type it. Capital letter license.txt. You can see I can read it. I have access to read it as all that is inside. We can all try all of these commands as long as we have the basic understanding of this concept that have been explained. Okay, so now let's go back to where we are. Okay, now the next one here, just as it is here, the first character, I've explained this, and just as it is here also, I have even covered this slide. So R for read, W for write. Okay, for directories. So now we are talking about, let's talk about the chmod command. The chmod command is actually the Linux command that is used for changing mode or permission settings of a file in a Unix or Linux OS. Okay, before I dive into this section, do we have question, observation regarding the way of presentation? And before we move on, in the next 5 minutes, let it come up. Let us hear from us. Hello.
I'm enjoying this section and you're really doing a good job. Thumbs up.
Thank you. Okay. Every other person, we have 4 minutes. In fact, we have 3 minutes.
Thank you so much. This is a
All
good
right.
session.
I believe.
Fantastic one.
Thank you so much. I believe every other person is the same response, so we can utilize the time left. Okay. Now let's go to the chmod command. The chmod command, that's the way I pronounce it. Sometimes I used to pronounce it as chmod, the way I pronounce it, but it's actually chmod. Okay, and the is a short form for what we call change mode. So chmod is a short form for what is known as change mode.
Ano apply?
So
Di mana
it is
mami?
is a
What's
command
up?
used. Okay. It is used for changing the mode or permission settings of a file in a Unix or Linux OS. All right, so now to use it, we specify the desired permission settings and the file or files that we wish to modify. It is illustrated in this way, this manner, where you have the command, and you have the options that you want to apply to the command, and you now have the type of permission, that is the type of modification that you want to apply, and then the file or the files. Let me come again. For example, let me use my um, mouse to explain. This is how it is. The syntactic representation of how to use the chmod command. You have the command chmod applying what type of option do you want to apply. Now, this option can be in form of octal notation, or it can be in form of plus, minus, equals to. Now, example of octal notation, it can be, you can apply permission of 300. I'm coming to what octal notation is for some of us that might not understand what octal notation is. I'm coming to that. So, for example, you can have 300, you can have 100 set on what? On the file. Okay, we can have it like this. We can have chmod. The option, I can say I'm setting 300 on the file, and I am setting 300 on file 1. This is how the octal notation work. Okay. For the symbolic notation, it works like this. This chmod command, I can have options of plus, minus, or equals to. Okay, let me put it inside this. And this plus, minus, or equals to can now be applied to either read, write, or execute. And then that is the mode. Okay, this is now the mode according to this, what is here. And then we can now have the name of the file name 1. Breaking it down, I can say chmod apply read apply plus equals to read option permission to file name 1. I believe everyone gets this. The symbolic is somehow is simple, and at the same time it's somehow, if you don't calm down to see, because of the too much symbols involved. Okay, so I can say the command, I want to change mode. I want to add read permission to file name 1. Simple. For the octal notation, I can say I want to change mode and I want to add permission 300 to file 1. Simple. Now, octal notation, what is 300? What is 100? Okay, now let's go. This is where we now break it down. Firstly, the octal notation method. The octal notation method represents permission using a 3-digit number, where each digit corresponds to a specific set or sets of permissions. And this permission is applied to either the user, the group, and others, or everyone else. Now, for the octal notation is based on three numbers, which when we add them together, in fact, sorry, it's 4 safe. 4. Okay, so it's based on 4 numbers, which with each of them having their permission name. For example, we have 4. 4 is for read permission. It is automatic. I've not gone to research why is it 4. How come did it? Okay, it's not automatic. Sorry, it is not automatic. We'll break it down. Yes. So we have 4 for read only permission, excuse me, and we have 2 for write only permission, and we have 1 for execute only permission, and then we have 0 for no permission. Now, the octal method implements its permission by converting the values into a binary numbering system, on binary numbering system, where permissions are set to on and off. Shikina. Now, what is octal notation? From the word octa, octa means eight and eight. Okay. So in numbering system in computer science, we have the binary, which is two bits. We have binary 2 bits. We have octal, which is 8 bits, and we have decimal, which is 10 bits. Or we call it base 2. Okay, base 8, base 10. Now, let me open a blank this thing so I can break this down. So in binary, we have base 2, whereby operations happens only operations happens only in ones and zeros, which are equivalent to on and off. And this is mostly used by the computer. This is the basic way the computer understands how you communicate to it. This is the basic way you can communicate for the computer to carry out command. Then, in fact, this is the basic way the computer executes all of its commands and instructions. And this is it is called the machine language. Binary on the language of the computer, or the machine language, is called the binary language, which is base 2. Then we have the octal system, which is base 8. And this ranges from 8 bits, from 0 to 7. That is 0, 1, 2, 3, 4, 5, 6, 7. If you count 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. So that's why they call it base 8, because it mostly consists of 8 bits, and the number range is nothing but from 0 to 7. Now we have the decimal system, and this is base 10, and this is from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We count everything, we have 10 bits. Bits is single. Bit is the smallest unit or form a computer can store data. Byte is equals to 8 bits. Okay. So now we still have another numbering system, which is hexadecimal, which is base 16. and this comprises of from 0 to F. This is 0 to 9, and then 10 to 15. Now, for the 10 to 15, this it has a notation, or it is illustrated with A, B, C, D to F. Okay, this is just a crash course. Now, what matters most now in this binary, in this numbering system, is that all of these systems are being used in one way or the other as we proceed, as long as computer science is concerned, as long as programming is concerned, as long as C programming language is concerned, to be specific, C itself, because C actually has opportunity to work directly with the computer architecture, with the machine, is closer to machine language. Okay, so what matters most is the ability to be able to convert all of these numbering system, octadecimal to base 2 as a final phase. So now, what we are dealing with basically here is the octal numbering system, which is for the octal notation that we are talking about. Now, look at this octal notation. We said it's actually the numbers for permission is basically four numbers, which is four digit 4, which is for read only, digit 2, which is for write only permission, 1 for execute only, and 0 for no permission. Now, how does this mean read only? How do we know that this is read only? Let me come to this place. Now, the octal notation method, as we said, the number for permissions are 4, which is for read only, 2, which is for write only, and 1, which is for execute only. Now, the pattern of the file and directory permission goes from left to right. It goes from left to right. A typical example, I said ls flag L is the command to list file permission. Okay, to list directories with to list files and directories with the permissions attached to it. All right. So now, for every of the file, the permission pattern, it goes from left to right, left to right, this way. It goes this way, left to right, left to right, left to right. So I'm trying to illustrate and explain what left to right means. So that means after we identifying what type of file or what type of data that file is, or directory, what it is, probably it is a file or probably it's a directory. After we've been able to identify it, the next thing is now the right permission, or the permissions goes from left to right. As we said that the pattern is also user, group, and others. Don't forget this. Okay, so as it is, the permissions go from left to right. That is, the first one is always read, the next one is always write to write permission, and the last one is always executable permission. So now, how does this work in binary? 4 in binary is 100, 100. If you convert 4 to base 2, you will have 100, and 1 means on. Okay, so in that case, it means that the read permission is activated. So that is why we said 4 means read only permission on a file. So as it is here, read only read permissions alone, and the rest is 00. That is, for write permission is off, and for executable permission or execute permission is off. So that means 100 means is 4 in binary, and it means read permission alone. 2 is 010 in binary, which means read permission is off, or write permission is on, and executable permission is off. In that case, write permission alone is possible when it is 2. And then 1, it means in binary is 001, which means it is only execute permission alone that is applicable to that file or directory or user or group or owner. This permission applies to file or directory. It applies single-handedly if we are using octal notation to either the user alone or the group alone or the others alone. And now I believe we can all attest that if we add all of this, and then we said there is, sorry, excuse me, there is the last one, which is, of course, 0 in binary is 000, which means no permission. Okay, so now if we look at it, if we should add 0 plus 1 plus 2 plus 4, this is equals to 7, and this is equivalent to base 8, which is equivalent to numbers from 0 to 7. That is why we call it octal notation. As simple as that. So this permission can be combined, therefore forming an octal numbering system from 0 to 7, 8 bits. So that is why we can have permission set on a file. We can say chmod 600 on file 1, chmod 725 on file 2, chmod um 777 on file 3, chmod, just as you can talk about it, there is no need. This is self-illustrative. Okay, so now when there's now a difference when you use octal notation. Okay, when you use octal notation, permission applies to this permission. Now if I'm to explain it, this is applying to 6 for user, 0 for group, and then the other 0 for others. So this is how basically octal notation works on 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 the set of persons affected. That is 6. This 6 is a permission that applies to the user, 0 is permission that applies to the group, and 0 is permission that applies to others. Now, when we now say 6, we already understand that the basic permission pattern or the basic set of rules for permission is only 4, 2, 1, and 0. But we are having 6 here. So that means it's a combination of 4, permission 4, and permission 2. So that means the user have only read, which is I have stylus pens that have been easy, but just bear with me. The user permission have the read permission. This 6 applying on the user means the user have only read permission and write permission. Shikena. Sorry, as I mean as simple as that. And then for group, no permission. This one, permission applies that 7, which is 4 plus 2 plus 1 is equivalent to read, write, and execute permission. On the user, it's becoming clustered. On the user, do we get? And then the 2 is indicating the write permission alone for group, and then the 5 is indicating the read and executable permission for for the others. Okay, I think this might not the best way to implement this, illustrate this illustration. If we want to illustrate 600, we have to illustrate it um, according to the pattern arrow, read, write, and execute. That is, for 6 now, we can break it down this way: 6, 0, 0, which can now be 6 means we have the read permission. Okay, let's say it's a file, indicates that it is a file. Now we have the read permission, we have the write permission alone, and then there is no other permission. And then if I break this down, this is dash 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 dash. Okay, for 725, this is for 725, this is read permission, write permission, executable. Okay, first the file, read permission, write permission, executable permission. Then we have which of the other one? There is no read permission. 2 is only 2, which is only write permission, and there is no executable permission. Then for 5, we have the read permission, and there is no executive permission, that is there is no write permission, that is 2, and 1, which is executive permission. If I expand this, make it big, you can see the triplets, breaking it down. Whoosh. You can see this applies to the user, the uh, group, and the others, which is now what? This is 725 permission. All these things will come out in the quiz. Probably some persons have gone through the quiz and through um the document I sent the other time. I don't know if the quiz is part of it, but you see it in the quiz actually. So this is just how it works, and this is how the concept. This is just explanation of the concept. I believe some persons are able to grab how the octal notation work. So the basic thing that is needed is understand the basic way of the permission model 4210 and octal from 0 to 7. And when it is 7, there is full access. When it is 2, you know that it is only write permission. When it is 4, it is only read permission, and so on and like that. Okay, let me stop here a bit. Probably questions, observation, and please let question come in, and then we look at the project, the listen I sent the other time. How will I say it? The PDF for the project that is, then we'll look at it and see how we can work about. Okay, I can see some things on the chart. Thank you. Please explain the octal mode again. Confused though. Wow. Sir, your 600. Are we still having issue with these um questions on the chat? Okay, the floor is open. Please let me have feedback. Oh, so I will do that. I'm talking to people. Wow.
Yeah. Hello.
Yes,
Hello. Can you hear me?
I can.
All right. My question would be on the 5 and 725.
Okay, let me
We
open it.
didn't actually talk about it. I wanted to know if it is 4 plus 1 or is there any other way to go around it.
The 725 permission, right?
Yeah, the 5 in particular, does it mean 4 plus 1? In which
Okay,
case it will be read and is it executable now?
okay, okay. All right. Now, there is a order. Let me. I think I did touch this. There is a order in which this in which you know how to arrange the permissions according to the number you see. You understand? For example, the basic number is we have 4, we have 2, we have 1 and 0. Now, when you are adding it together, you need to make sure that you follow the pattern or the order. That is, this is always number 1, this is always number 2, and this is always number 3. Okay, let me create a new slide so that I can make this bigger because I think they are small. Okay. Now, now the order we have 4, 2, 1. No matter the number, if you have permission set to a file like sorry, let me take this away and put this up. There can be space. Number 1 is always 4, 2, 2, 1, 0. So no matter the way where it's coming from, if you have, for example, just like the one we talk about, 725. For me to put them like this, okay? For me to sum up 725, for the first one, which is 7, it has to be 4. Then for me to amount to 7, the next thing I'm to add is 2. And then the next thing I'm to add is 1, which is equivalent to 7. This one is simple, is straightforward, right? Now, if you have the other one, which you have 2, 2 also is straightforward. 2 is just 2. Okay. Now, when you now have 5, I know this is where you are trying to contemplate. How do you add? Do you add 4 plus 1 like that? Or how? Now, this is it here. You follow the pattern. The pattern to add the 4 is 4, which is for the first one. I said I explained that the order or the pattern that this thing works, it works from left to right. Where is it? This is it here. The pattern for applying the permission, it works from left to right. And the left to right is read, write, and execute with each of the number 4, 2, 1. So there is no how, no matter what the number is, you must follow the pattern. So now for 5, the first one is 4, which is to read permission. Now there is no write permission. That would be dash, and then 1, which is equals to 5. That's why I was trying to illustrate this with the notation where you have RWX and all of that, just like this. The first one, the indicator of the file, the indicator that this is a regular file. Then the next one is where you have the setting of the permission. The first one we have 7, and this is equivalent to, okay, this is equivalent to read 4, read, write, and execute according to the order left to right. For 2, I wish I have a stylus pencil. This should have been easier, and by this pen rather, should have been easier. I would just be writing on the board. But
Hello, could you bring it down, like instead of it going other?
okay, let me take this away. So for 2, it's just 2, and this implies there is no read permission, but there is write permission, and there is no executable permission. This is a symbol. For 5, 4, no write permission, 1. So there is read permission, there is no write permission, there is executable permission. That's it. Is it clear?
Yeah, thank you. It is exactly what I had in mind. I just wanted to be sure.
All
Thank you.
right. Any other person? Let's
Sorry,
talk.
can you go back to the CH mode part where you were explaining the signs, positive, negative, equals to?
Okay. Okay. The other time I said there are 2 ways of specifying permission in Linux, of which we have the octal notation method, which involve numbers from 0 to 7, and then the symbolic notation. The symbolic notation involves the use of UGO, and where you have like this, an example which I gave, I said the mode, the command, and then what are you specifying, what are you setting, and then what exactly are you setting. Okay, are you this plus, it can either be plus or minus, you understand, and then the command, the permission itself that you are applying, and then the file name. Let me open this. This is when we, to make this very explicit and make it comprehensive, is when we come to symbolic notation. Let me just go directly to symbolic notation and explain. I think this will make it easier. The symbolic notation is actually quite simpler, or probably convenient, than the octal notation. But me, I prefer the octal notation because it is just straightforward. You have the numbers as long as you understand the concept. So before I actually just go into the symbolic notation in the next, I will take that for just about 20 minutes. Does anybody have any question on the octal notation? We are moving to symbolic notation now. So let us make it that way, organized. I think nobody. Okay, so now let's move to the symbolic notation. I'm going to use this web page because I didn't create slide for that. I'm going to send this link. This place is always good to understand the Linux permission also. Okay, now this is how the symbolic notation work. This is the format. You have the command chmod, and then what options are you setting, and on what part or on what set of user are you setting the option on or the permission on, and the plus minus, are you adding permission or are you removing permission, or are you applying, okay, are you adding permission or are you removing permission? That's just it. It can either be minus equals to or plus equals to. Okay, I'm going to go to my slide and break this down because I know this might not be explicit. And then the exact permission that you are setting on the file. The command, I want to set permission, extra option. What permission, who are the people I'm setting the permission on? Is it for the user, for you, for the group, or for others, or for all of them? I can put the three UGO, meaning for every one of them. This A means all, okay? And then, am I adding permission? That is it plus equals, or am I removing permission minus equals permission or permissions? It can be more than one on the set of files. This is what it is here, according to what is explained here. The first set of flags, UGOA, it means user flags, defines the user classes. Okay, okay. And this is what you have: U for the file owner, for the user; G for the users who are members of the group, that is the group; and then O for other users or everyone else, just as explained. When this flag A is applied, it means all users, and it is identical to what? UGO. I can use UGO alone. I can do CHMOD UGO alone. I can do CHMOD A alone, applying permissions to every of the users. Okay, I'll still break it down. It might not be explicit enough. So now the second set of flag is now what? The operation flags, defining whether, just like I said, whether the permissions are to be removed, to be added, or to set. When it is minus, it means remove permission. When it is add, it means add permission. And when it is equals to, it changes the current state of the permission to whatever I want to set. And then, what are these permissions that are applicable? Just like we said, okay, we have R for read, W for write, X for execute. You know, I'm not too sure of these other symbols, but I think the description is below. So now, according to the question of the person that has the quiz, I don't know, I didn't check the name. So we have this example, the chmod, the command. I'm changing the mode. Okay, I'm setting permission on the group user, and I'm setting all of them to have permission to execute on this file. Let me come again. Let me take this to my slide. No, let me take this. Just like we said, so the chmod command to set permission, the different set of options, and then what am I setting? Is it on the user group or others or all of them? Am I adding or removing permission? The permissions or permission itself on the file. And look at the typical example. We have ch mode, and we have something like, it said G equals X on file name 1. This means Do we get it? So saying that what this means is saying set the permission on the group members to have the right to execute this file, file name one. No, in Linux, naming system is case sensitive. This is different from this, but I'm just using it for as educational purpose, just to illustrate. Okay, so we can also have another way of setting permission using the symbolic mode. You can say change the mode of the user, the group, and the others. And I'm adding executive permission to file name one, no comma, file name two, okay, file two, file three. So this is saying that you are adding executive permission to file one, file two, file three. Okay, let us practicalize this to make it more understandable. I'm going to do the practical based on octal notation and based on symbolic notation, so everybody can be able to see. So let me clear the screen. So, can this work on? Can this work on Git Bash? Okay, it can work. Okay. So now let me create a file. So let me create a directory. Um, oh, okay. I can't do that on this very place. What do I do? What do I do? Okay, okay. Okay, allow me to run my virtual box. Few minutes, please. I'm sorry. We're going to end this class soon. In the next 10 minutes. Yeah. Start. Okay, let me connect to my intranet. If that one is fake, is wasting time. I can have access to the Ubuntu on the intranet through the sandbox. So
Hello, can you hear me? Sorry.
yes,
I was going to suggest using Windows PowerShell instead of you using your your intranet. Would that not work?
yeah, the PowerShell will not work unless I connect a virtual box like Vagrant to it. My virtual box has come up. The
Okay.
PowerShell is still different from you have for you to use a PowerShell, you have to install a virtual Ubuntu or Linux OS on it. That's that's how it works too.
Uh,
My terminal is back. My virtual box is back. Sorry. Let me run it. Uh, let me run. Okay. So just pray this is not slow. Okay. Right. Yes. So I can make a directory now. So make directory shell permission cd shell. Okay, I'm inside. So firstly, okay, let me even do cd dot dots. Let me list the files here to list. Ooh. Okay, let me enter back because time my system will go off now. So now let me create a file. Let me just say touch file 1 on file 2. So now we want to add permissions to the file. We want to add permission. Oh God! Yay!
Your system is off.
So looks like it. Hello, are you still here?
I'm guessing he probably lost network or something, but still here.
His laptop is off. I think the battery is low or something.
Yeah, I suppose his battery is low. Well, let's hope he'll come back in a short while.
Okay, let me just ask this question for those of us who are following very well. I need a clarification on something. For the octal mode, octal notation, can we have 300? And if we have 300, how do we split the 3? Thank you.
All right. Should I? I want to take that question. Should I? I don't think he's here. All right. Okay. So you said we have 300. In that case, it means the 300 will be taking the that'll be 2 and then 1. It means the fork is empty. It means there will be no read permission, but there will be write and there will be executable. I think. But my stand to be corrected. Is it Abishola? You may want to cut in.
Sorry, the question again.
And okay, said 300 instead of say C mode 300 and then the rest of the line like that. So you're saying what does that mean? What kind of permission is that? And I answered that it means you have 2 and then 1. It means 4 is empty. That is, there's no read permission. It means the user is going to have write and executable permission. Am I
Okay,
right?
so yeah, you're right. It means 300. So that's 3, which is 2 and 1. That's write permission and executable permission for the user only.
For the user
Then
only.
then the 0, um the next 0 after the 3 is, it means that there's no permission for the group user. And the last zero means there's no permission for others. Do you understand? So if it is let's say if it is 732, let's say 732, it means that the first person, which is the user, has all the permission, which is 4 3, which is 421, that's 7. That's read permission, write permission, and executable permission. The 3 means the group users, they have just the write permission and executable permission. And then the 2 means the others, they only have the write permission. Do you understand? Hello?
I don't know.
Yeah, no, you really made it very clear.
Am I
Yes.
making sense, please?
Yeah,
Yeah.
you make a lot of sense, really.
Yes, you are
Okay,
making
so I think the basics is just for us to understand the logic behind it. 4 is read only permission, 2 is write only permission, 1 is executable permission, and 0 is no permission at all. So
Okay,
that's
can
just
I ask a question there?
okay.
Yeah, so on the octal mode, does it mean like when we have say 641 or something? I don't know. Uh, the 6 represents the what is it the user?
Sorry, come again.
Yeah, supposing we have say 641.
Mm-hmm.
Uh, would the 6 represent the user? We have
Yes,
the user.
yes,
The,
yes. Like he explained, he said the permission comes from left to right. If you can remember, it says from left to right. So you can't start from right to left. It always comes from left to right. So, and from left, you are picking it from the user, the group user, and then others, which is 641. So if it's 641, then it means the user has read only permission and write only permission. That's read and write
Mhm.
permission. That's 2 permission. It means the group others, which is 4, has only the read permission, and others has just 1, which is executable permission. Do you understand?
Yeah, no, it's clear. Thank you.
Okay, you're welcome.
Mhm.
Okay, thank you so much, Abisola. Now, when you have 010, how do you know whether you are in binary or octal? If you have 010.
I think we'll wait for Bamidele to answer that one.
Okay. All right.
When
Let me take that. I think if you have 010, I think there is no binary mode or something. There are only 2 modes. There is symbolic and there is octal mode. Like according to what is said.
yeah,
So
you're right. You're right.
if you
Yes.
have 010, it means there is no permission for the user. There is only executable permission for the for others. Is it group? Okay, group, and then there is no permission for everyone else. Do you understand?
Yeah, that's understandable, and I also think the way I look at it, it's like we use binary to come up with the calculations, but in the presentations we don't use it. I'm not sure if that also helps.
I don't totally get what you just said, but for this ch mode command, the ch mode command itself, there are only 2 notations. You can only do it in 2 ways. So the first way is the octal notation. The second one is the symbolic notation. Do you get that? So the octal, whenever you see numbers, it means you're talking about octals. But when they are symbols, that is a plus, minus, and equal to, you're talking about the symbolic notation.
Yeah, no, that is clear. What I was saying is, uh, of course, we know that the calculations we make them using the binary as he explained. So we know in the back that we are using binary, but in the presentation of the whole thing, we don't see the binary there. So
Okay, I
that
think
means
I get what you're trying to say. He just used the binary to explain how we came about maybe using 300, 600, to
yes,
indicate permission. So it's
yeah.
not like
So
the binary is being is shown in when you are putting in
exactly,
the command. Yes, when you are executing the command or when you are
yeah,
trying to put in the command. You just use the
yeah. So
binary to
this,
explain how we came about the 421 and the octal notation method. That's what he just used it to explain. So the 2, like the guy explained, we have just 2 method of ch mode. Is it ch mode? Yes, ch mode. We have 2 types, 2 methods, which is the octal notation and the what is the other one? The octal notation
Symbolic.
It's
and the
symbolic.
symbolic. Yes, and the symbolic. So the symbolic is using the plus or negative sign. The plus sign is showing that you're giving the user or whoever and the others permission, or whoever you want to give permission. And the negative sign is showing that you're not giving them permission. Do you understand? Hello?
Yes, very clear now. Thank you so
Okay.
much.
Okay.
All right. I don't know if does everyone understand. I don't think he's coming back. I think he's gone for now.
Anybody that has questions should ask. Let's see if we can just help him cover up.
Okay, he
Okay.
says he'll be back in 10
So
minutes.
we'll be back in 10 minutes.
Yeah, yeah. So that's about 7 minutes from now.
So are we waiting for him, or what are
I
we
don't
doing?
know if anyone has questions. They should probably ask. Or I don't know.
Yeah, I suppose we wait for him as he requested, unless if somebody would have a way to maybe uh, show the screen and show us some things. Otherwise, I suggest we just wait for him.
Nothing.
Hello, guys. Oh, Jesus. Hello.
Yeah. Welcome back. We're here.
Welcome
Welcome
back.
back.
I'm sorry.
We still are waiting for you.
Thank you so much. I
Okay,
apologize for that. Mm-hmm. So I will have to restart my. Okay, let me share my screen back again.
all right.
Mm.
Okay, before he shares his screen, guys, I hope you remember where it was explaining these symbols AUGO. So he said A stands for all. That is when you are using the symbol notation. A stands for all, U stands for the user, G stands for group, and O stands for others. I think that was where he stopped.
Yes, I was trying to explain the symbolic notation, and of course, just like you said, for for the symbolic notation, instead of using numbering system, just like the way the octal numbering system, just like the way it is in octal notation. In symbolic notation, you use symbols to carry out your um, to set permissions. You understand? After the CHMOD, for the octal, you write numbers. Okay, but for the symbolic, you put symbols that have different meanings according to what you are setting. So, for example, if we are setting permission for only the okay, hello. That's not me. So, for example, if you are setting permission, set permission for users alone. That's where you have for For owner, they used to call it owner, or you call it user. Okay, for the owner alone, that's where you have CH mode. In fact, I didn't even specify what permission. Set, read, write, execute, permission. That is RWX for owner alone. This is how it will look like. CH mode user alone plus equals RWX file. This instruction is not complete. For owner, I'm sorry, set read write executable permission to file 2 for owner alone. So this is complete now. So I'm setting read write executable permission to file 2 for the user or the owner alone. And this is how it is in a symbolic representation. Okay, so in a symbolic representation, if it is for group alone, this will be chmod g plus equals read write executable for file 2. For others alone, this will be chmod o plus equals read write executable file 2. For all of them, chmod ugo, that is for user, for group, for others, plus equals read write executable on file 2, or chmod a plus equals read write executable permission on file 2. This is it. So we are trying to look at an illustration. So I'm inside my terminal, and I created a file touch2 the other time. So now this file, now if we list the file and check uh, the permission rights on it, it is a regular file, just like we said the other time. Okay, and it has read permission and write permission, but it does not have executable permission because it is not an executable. I talked about the colors that is used for differentiating a file from a directory to an executable in a shell, in a terminal, on the terminal. So those things are just like guide for you to really know what, aside the fact that there's a command that will specify the properties of the file or the directory, but having this color too is a guide. All right, so now this man is an executable. That is why it is white, and that is why this place is what is having nothing there. All right, so now let us add an executable permission to file 2. Adding executable permission to file 2. I'm just writing, this is Linus. You cannot do all this. You cannot run this command. So now let us do this using, okay, we want to use the symbolic system. Okay, executable permission, as we say. So now we say change mode of the user. Remember, which side are we changing? The user, this side. If it is the group, it will be this side. It will affect. It will be it will affect, because at the point in the project, they will specify the side you have to change permission on each of the file. I really want everybody to just get this as soon as possible, and even me explaining this will make me to understand this very well. And the main place that we need to focus work on is that C. When that C starts coming, it look like heaven and hell in the same place. But that I'm not trying to make us to fidget. So we need to be very pay attention to details. Linus will make you to be patient, and it requires attention to details. So now this side, the user, this side, these triplets for the group, and these triplets for others. So according to the instruction, we want to change we want to add executable permission to the user, to the user property. Okay, we want to give the user executable property. All right, sorry about that. So now change mode of the user, that is why we put u there. Add equals to add plus add executive permission to which file? File 2. Simple. Now let us see the magic. What will happen? ls has changed color or not? Are we there? And if we
It,
do a long listing of property, ls minus l, can we see? Now, good. Something has happened. Probably uh, somebody will see something has happened. The indicator, this is where now it now become task practical now. The indicator here, um, it is a regular file. This was what we had before. There was only read, there was read permission, there was write permission. Okay. And now it is now having only executive permission. And why is it like that? This is because what we set here is only executive permission. We've changed it to have only executable permission. Let us change it back to have both read permission and executive permission on the user. So change mode u plus equals to read permission and executive permission on file 2. Let's ls long list. Can we see it now? Let us now add read permission and write permission to it. Change mode to the user, add read permission, add write permission, add executive permission to file 2. Now long list L, isn't it there? We can see now that the user have the read part access, the write access, and executable access to it. And this 3 is for the group, and this 3 is for the others. So now that means as I do ls, this man can be run like a script. If I write script, if I write bash script or shell script inside this man, I can run it and it will perform the job. This aspect now, they will ask us to do it in the sense that they will ask us to write a script that will perform the function of listing file. Instead of using ls, we should create a script that lists file. So it has to do with we writing the script inside this file too to carry out that option. So now I believe this symbolic aspect is a bit understandable. Let us do something else before I switch to notation, and then will open ground for question. Okay, let me do let me add executable and read permission to the group of this file, to the group members, that I want group members to have read and executable permission. So I'll say change mode. Okay, for the group, alone add read and executable permission to file 2. For the group alone, add read and executable permission. List file long listing. Can you see it? And as I said the other time, I've talked about a lot of things. I talked about the pattern and the order of applying permission. I said it is from left to right, and I talked about the order, that the first one is always read, the second one is always write, yes, and the last one is execute. And just as you can see, there is, for this man, there is read, you don't forget indicator, and then read for the user. And now we are on the group, there is read permission, there is write, there is no write permission, but there's executive permission for these three. Okay, so now let me clear the screen. Now let us use the octal notation. Let us change and create another file. Let's call it file 1 because we don't have file 1 initially. So list file. File 1 is a regular file. Let us list the properties. For file 1, we can see what we have here. It is having, the user is having read and write permission, but it's not an executive. Okay, so now let us add permission 600 to file 1, and this permission, okay, permission 600 to file 1, let's just do it like that. Let us do it like that. So let's say CHMOD permission 600 on file 1. Now let's see what will become of it. So ls long list L. Can you see? Remember I said for octal notation, everything is dealt with individually. Okay, everything is dealt with individually. 6 is applicable to the users alone. 0 is applicable to the group alone, and the other 0, the last 0 is applicable to the others. Okay, so looking at what we have here for file 1, it is a file. 6 is a combination of 4 and 2. Okay, and the order is 4, 2, 1. 4 meaning that it has read only permission to read alone. 2, it has write only permission. 1, it has execute only permission. So now 6 is a combination of 4 and 2. So 4 meaning that there is 4 inside of 6. That is, this file 1 we have read only it will have read permission, and there is 2. That means it will have write permission as well. While for the others 0, 0, we have said that they should not have any permission to the file. I think this is explicit. Let us change it and make it that all of them should have read permission, write permission, execute permission. And that number is talking about addition of all the numbers that we talked about according to the permission model 4, 2, 1. That is read permission for 4, write permission for 2, 1 permission which is for execute. So adding the 3 together, we have 7. So that means we are saying CHMOD add 777, okay, to file 1. Add permission 777 to file 1. And yes, let's check it. Can you see it now? You can see that file 1 has turned to green because there is an executable property on it. And looking at it here, everything, all of them, I think this is clear and if there are questions, we can take it from here. So let questions come in and clarification. Guys, okay, chats.
Okay, thanks a lot for the explanation you provided. It's really worthwhile. We really are very happy that you are giving us this lesson. Okay, anyway, I wanted to ask. I saw when you are working on the symbolic, yeah, the symbolic version of the whole thing, and you were uh, giving permissions. There was a time when you gave the permission. Of course, you said we start from the left to right, and when you change
Yes, sir.
from um, was it from the user to the group, it sort of over did it override the other ones? Yeah, my question really is, when do we happen to override the other permissions, and when are they kept? Because I think when we were moving to Octal, the same thing was not happening. Like in the Octal example that you made, you we had permissions for the users, and when you move to the group, those permissions for the users were still there. I on the other example, it seemed to override them. So I think if maybe you can explain on the overriding of uh, the permissions as you move on the others, it's not clear to me, I think.
Okay. Okay, if I can get your question. While I was using the symbolic notation, while I changed the permission for file 2, while I specify for the user alone. In the process of setting a permission, it overrides the initial permission that the user had before, right? Into the single one. For example, when I did user plus equals to X, it cleared the other things that is there and add only executive permission. But the other ones are still like that, if I am correct, but with what you are saying. For example, let me particularize it. If this is what you meant, I'm adding executive permission. Okay, let me create a new file. Touch file 3 in mode. Let's see what is there before. Okay, we can see what the user have and what the others have. So change mode uses symbolic. For the user alone, I'm adding executive permission. Okay, and to file 3. Okay, so if you now do long list, the, look at this is what we have before. This is what we had before rather, and this is what is now there. The write and read permission is gone, and it is having only executable. Is this what you meant? I think this is what you meant, right? Is it has overwritten the previous permissions.
Yeah, I'm trying to go
Hel-
through it and to process it in my mind to see if there is maybe, I don't know. Let
yes,
me see.
you can compare. You can compare.
Yeah,
This is the permission I set. Please let me check it before. Okay, this permission I set.
yeah,
I
yeah,
this is the result of the permission I set. Okay,
yeah, yes,
this was the previous one,
yes.
and this was the command. It's overwritten. It overwrites it, right?
Yeah,
This is what you
it
meant.
just, of course, okay. No, this one is clear because it only overrides on the user the read write to only have uh the
Executable.
yeah.
Yes. Okay. Okay, that means the what you meant is for the symbolic while I did 600 and the other ones was not having any permission. Like, okay, let me do another thing. I did touch.
Sorry, I think this is what I meant.
Okay.
Are you there?
Yes,
Hello.
I'm with you.
I think this is what it meant because as we can see, it overrides write the read and write permission. So what we
Yes,
can see is only the executable permission for the user.
yes. That was what I was trying to clarify.
Yep.
If that is what he meant,
Yeah,
okay. Okay, now
because
let's.
it's supposed to show. For me, I was thinking it's supposed to show all the permissions for the user.
Okay, okay. Now I will tell us why it happened like that, and then for the symbolic too. I think I'm trying to picture what he's trying to talk about again, and I'll go back to the octal rather. Okay. For this permission here, we have chmod u plus equals to x. Now, this plus equals to, it's saying that change all the permission of the user to executable alone. That is why we have only executable here. Change all the permission of the user to executable alone. That is why we have this man here. Okay.
Okay.
Now, when we want to specify, for example, now let us assume this file tree that is having this executive permission alone for the user. Let's assume that we want to add a read permission to it, such that we don't want to repeat executable and read. This is it here. This is what we can do. That we will preserve the executive permission, and then we'll still add another permission to it. This is it here. We will do chmod to the user add read. This is how it will look like. Because if I put equals to, it will add whatever permission that is there. It will add it alone. Okay. But when I say you to the user add write permission to file 3, okay, with this, it will preserve the existing permission and then add this new permission for me. And let us see. This is write permission, no, don't forget. So if I list a long list file, can you see it now? I believe this should be clear now. I, I want to mute. Uh, what's that?
Can you please put off your
Hello. So I think we can see this was what we had before for file 3. It has the executive permission alone. But now, from here, we added the write permission to it, preserving the whatever existing permission it had before. And looking at the results, the write permission is added to it. And basically, our task on ALX project, this is how we are to do it. But the first illustration was just to show us This first illustration shows that whatever permission, when you use plus equals to, it adds that permission alone for that user or group or order. But when you just put the the party that you are applying the permission to, probably is just the user, just like this. When you put plus alone, that means you are adding permission alone. You are adding the permission to the user and preserving the previously existing permission. Okay, I'm going to do something in order to make this more interactive, practical, and also to make us think. At least we've been able to get the concept. What is now needed is for everyone. There's a need for everybody to think. So we won't spoon feed us with almost everything. We have to now think by ourselves. So now let me work on the octal notation. When you have 600, I said if you have something like 600, this will apply to user, all group, and then others. So looking at it, this will apply to user, group, and order. Whatever permission you put there, even if you have 000, permission is accordingly. This will to apply to the user, it will apply to the group, and it will apply to the others. And that is why they call it octal, because looking at the octal, it will combine all of the permissions. It can combine 4 and 2 together, but everything will not exceed 7. You cannot have 8, you cannot have 9. It is wrong. There is nothing like that. It can either be only from 0 to 7. There is no other thing again. Okay, so now, why the previous permission that I said before, I said change mode. Let me create another file, touch 4, and touch file 4, and okay, sorry. So we have file 4. Now, this is the permission of file 4. Now, let's say the question is change the permission on file 4. Let's be attentive, please. Change the permission on file 4 by adding write permission to file 4 only to the order to the others, or how will I say it? We have user, we have the group, and we have the others. Okay, so change permission of the others. Okay, of file 4. Change add write permission to it. Okay, so add write permission to the others of file 4. That's what we want to achieve. Okay, look closely what we have here. This is the others of file 4, and this is strictly using octal notation. Okay, so the first thing that we need to understand is, I'm coming. It's so hard. I think there is pen and barrel, it would have been easy. Come in. Just a minute. That's simple. So first thing, Octal notation to add write permission. To others alone. That's what we want to achieve. What is the octal notation? To add write permission. Remember, we have 4, 2. 4 is for read, 2 is for write, and 1 is for executable. So automatically, the number system will be 0. We said to others alone. Alone. Okay. So that means, and I said something about the octal notation that we have three. They are in three. We have, let's say, 000. This applies to the user. This applies to the group, and this will apply to others. So that means they said others alone. That means the pattern, the number will be 0, 0. And now, what is write permission? The permissions 4, 2, 1, 0, which is equivalent to read, write, execute, no permission, respectively. So what we are having now to be for the user 0, for the group 0, and then for the others we are adding write permission, and write permission is 2. So 002. That's just it. So what am I going to do here? For the others now alone, for file 4, change mode. Change mode or set mode 004 to file 4. Now let's list. Sorry, I did 004. Hello? It's supposed to be 002, what we have here.
002.
Yes, but I believe we could see what happened. So 002 file 4. And you can see write permission alone to file 4 on the others category itself. So now, how can we execute this using symbolic notation? Somebody should write it on the comments, on the chat box. Oh yeah, how can we do that? Setting write permission alone to others, other users on file 4. Anybody? The screen is open. This is what we are working with. Somebody should type it on the comment on chat box. Change mode. I'm seeing something. Others plus equals. Okay, let's try it too. This is what I have. I'm copying it. I'm copying. This is from Sheriff. Okay, and I have another one from Abisola, and I have another one from Ibak. So we'll try all of them. I'll try. This is it here. Let me create file. I'll create Sheriff file, and I'll do according to his answer. Is this? He said change mode 0 plus equal to write file 4. Oh Jesus. Sorry, Sheriff. Okay, so another person, touch Abisola. Okay, so change mode. She wrote 0 plus W Abisola. The next person, change mode. He back. She wrote, wow, dash 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 W. I have to create a file first. Change mode. He back. Dash 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 W. He back. Wow, we have an error with that. We have another person. Let's script that. Touch Ramosamo. So change mode. 0 plus equals to W Ramosamo. And then we have the last person, Brandon. Touch Brandon. Okay, we have change mode. Change mode 0 plus equals to W Brandon. All right. So I want to remove file 1 to file 4. We are not using them. Oh, you see, based on permission of file 4. So that's it. Okay. So we have our file according to Abisola. Now let's go back to the question so that we won't mix it up. We are adding right permission alone to others. We are adding right permission alone to others. Okay, to the others group. Okay, so long list Abisola. So what we have here, we added right permission, and I think this is wrong because what we should have alone, we should have, let me list the other ones. Brandon. So to make this organized, this should be the expected output. Should be expected output. We should have dash 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 read dash dash. This should be the expected output. Okay. So list files, long list, ebac, list files, long list, Ramo Samo, list files, long list, Sharif. Can we see everyone? Hello.
Yeah, we can. I can.
So we can see that
We are with you.
our our output. Okay, I think nobody got it actually. The expected output and what we add. So this was the command. Let me create my own file. So this should be the result. Change mode to the others alone. Okay. Okay. Yes, 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 of course. Of course. Of course. Change mode to the others alone, right? I'm thinking. I don't know the answer to using symbolic. So I'm thinking probably.
Hello.
So we are changing mode alone to the others. to the others, right? Okay, use adding right permission alone. So what this has to be is step by step. You have to remove all the permission for the user, for the group, and then add right permission alone for the others. Do we get it? So this should be UGO. I want to do UGO minus all the permission for Mike. Wow. Okay. Okay.
Hello.
Yes, I can hear you.
Okay.
I'm brainstorming on the answer too, using
I want
symbolic.
to give you a suggestion to yours that you're typing. I think first you have to, according to what you've like explained to us, you have to remove the permissions for everyone. That'll be RW hex for everyone, UGO minus equal to RW hex, right?
Okay. Yeah,
And then I think there is space.
exactly. You're right. Exactly. So where is bits? Uh, I think that's added. It should be equals minus. I think so. Okay. Let's see. Equals minus.
Wow.
Hmm. Yes. Okay. I think we are learning something. Everybody's paying attention. So plus minus add plus equals to or minus equals to is different. So when the equals to comes, it performs another action. So to remove everything using symbolic, we had I don't want anyone to get confused though, please. So if you have change mode for the user, for the group, and everybody, if you do equals no space equals minus, this removes read. If you say read write, this removes up read. This removes read, write, and execute permission on all the groups, all the users. So our answer should be UGO. With this now, we've run that. So for this now, our answer will now be for the others alone plus equals right file name. So this is what should be our answer now. Okay. So when we clear screen, we now say CHMOD for the others plus equals to right permission Mike. Let's long list. This is it. Is it clear?
Yes.
This man will die again, and power is even out finally. Any other question, clarification, and then probably we can call it a day from here, and then we'll look at if we can fix another class tomorrow.
Okay, so can we? Obviously, we could have also have just said CH mode instead of saying UGO CH mode A, then equals to minus. Is that true?
Yes. Oh, let's do that before this man dies off. Oh, where is it? Where is it? Before this man dies. Let's try it. I shouldn't have restricted it to. Okay. Okay, let's try that on Sharif. So CHMOD A, okay, equals minus read write. Yes, LS long. Exactly. Yes, and then we can now do CHMOD others alone. Okay, it's gone.
Hello everyone. We lost each other now, eh?
Yeah, it's gone again.
Okay, I wanted to ask anyway, but I suppose we can look into it on our own. He had also talked about preserving the permissions using something like say 0 plus W. If maybe we had executable permissions, then we just want to add write permissions. We can just say 0 plus W on the other mode. What do you call it? So I wanted to know, how do we do it on the octal mode? But I suppose it's something we can think about and uh, get to know how, unless if somebody has the direct answer right now.
Okay, I think for octal modes, you you are at liberty to from the start do whatever you want. You depends on what your numbers are. That is what gives the permission. There are only three numbers you have to look into. So you put 300. So you say CH mode 300. It means you are giving only the user what is it called now, the write and execute permission, but not the read permission. Do you get that?
Mm-hmm. Mm-hmm.
Yeah.
Okay.
So
Okay.
you
Okay.
are not giving any permission to others and I think everyone else or the group. Yeah. Do you understand that?
Yeah, I think I do. I think I do.
And so I think it depends on what you do. What you do is what determines the permission that gets in. I don't think it has much manipulation compared to the
Okay.
what is it called, the symbolic mode.
All right. All right. Thank you very much.
You're welcome. So I think he plans to come back tomorrow. So I say we call it a day. So, unless someone else wants to say something.
Yeah, I would also suggest we call it a day. I think it was really a very beautiful session, really. I personally benefited a lot from this one.
I don't think anyone would say otherwise. It's been a
Mm.
the time has been worth it. So thank you
Yeah,
everyone. I'm leaving from my hand here.
yeah, we are really lucky to have him.
Yeah.
All right,
And of
guys.
course,
Bye.
Okay. Bye.
okay, bye, guys.
All right, bye everyone. Thank you so much, guys.